All right, so we're ready to go over these answers now. Everyone's had a chance to try them. Try to make the font so that it'll pick up by the camera. All right, you have a 12 molar HCl stock solution. You dilute a 5 milliliter portion you take a 5 milliliter portion and dilute it to a total volume of 200 milliliters. So again, like I warned you, be careful in how this is worded, right? Because when you're setting this up, M1, V1, M2, V2, M1 is 5, right? V1 is 12. M2, that's what we're figuring out. V2, is it 200 or is it 205? 200. It's just 200. Why is it 200 and not 200? Because it says to a total volume, okay? Remember, I said be careful about how it's worded, because if I said you add 200 milliliters to it, then V2 would be 205. But I said you dilute it to a total volume of 200. That means you added 195 to it, right? Does everyone see why V2 is 200 and not 205? All right, so now we just do our arithmetic. M1 V1 equals M2 V2. These both are in milliliters, so we can just plug them straight in. So 5 times 12 is equal to M2 times 200. Okay, we can only keep 2 sig figs, so when I did the math, I got 0.3. M2 is equal to 0.30. Do we agree? Yeah. Any questions on how to do number 1? Or how we set it up? All right, let's take a look at number 2. Zoom out a little bit. Okay, you have 500 milliliters of a 0.087 molar NaCl solution in your lab storage room. You see in the prep notes that it was made from diluting a 40 milliliter portion of a concentrated solution. What was the molarity of the original concentrated solution? So can you work backwards to find out information about it? Yeah, you can. That's not too bad. So we just need to set it up and make sure we're solving for the correct variable. So M1, that's what we're looking for. V1 from diluting a 40 milliliter portion, so that's what this 40 comes from. M2 is 0.087. V2 is 500. Do we agree in how all the pieces get plugged in here? Yeah. So again, we're just plugging in M1, V1 is equal to M2, V2. So M1 times 40 is equal to 0.087 times 500. So M1 equals, we can only keep 2 sig figs because, I know we can get right there, 2 sig figs. M.1, 1.1 moles per liter. Do we agree on this one? Yeah. Any questions on how we do number 2? All right, let's look at number 3. So this is kind of like a health setting, working maybe in the pharmacy at a hospital or something like that. You have a 1.75 molar glucose stock solution, and you need to prepare 25 milliliters of a 0.1 molar glucose solution for a patient's IV bag. What volume of the stock solution should you use, and how much water do you need to add to dilute it? All right, so first, let's solve for the stock solution part. M1, V1, M2, V2. M1 is 1.75 molar. V1, that's what we're looking for. M2 is 0.10 and V2 is 25. Do we agree in how we set this up? Yeah. Yes? All right, so M1 V1 equals M2 V2. So 1.75 V1 is equal to 0.10 times 25. So I got V1 should be 1.4 milliliters. Do we agree? Yep. And then, how do you know how much water you need?
Subtract 1.4 from 25.
Right, you want the total volume to be 25, and 1.4 of that is going to be coming from the stock solution. So it's just 25 minus 1.4. So what do you get when you do that? 23.6. Does everyone see why you need to subtract in order to figure out how much water you need? Because you want the total volume to be 25. 1.4 is going to be coming from here, so that means the rest is going to be your water. How do you feel on this one? Good. Thumbs up? All right. Let's look at number 4. Very similar. I think it's actually pretty much identical in terms of how you do it. The lab stockroom contains a big flask of 2.5 molar potassium iodide solution, but you need 150 milliliters of 0.75 molar solution. How many milliliters of the stock solution should you measure out? That's bad grammar, but that's okay. How much water do you need? So let's figure out this one first. Don't tell anyone in, the public speaking or whoever about my sentence ending in a preposition. All right, M1 is 2.5. V1, that's what we want to know. M2 is 0.75, and V2 is 150. So M1 V1 is equal to M2 V2. So 2.50 V1 is equal to 0.75 times 100. Oops. So V1 is equal to, I got 45 milliliters. Do we agree? And then how much water do we add? Well, the total volume needs to be 150, and 145 will come from the stock solution. So 150 minus 45. Right, so what do you get? 105. How do we feel about this one? Good? Any questions on these kinds of problems? All right, number 5 is very similar. And they're all very similar. It's just watching how the problem is worded and what the problem's asking from you. So number 5, not number 6. You take 15.25 milliliters of a 10 molar solution and add 120 milliliters of water. What is the volume of the new solution? How do you get the volume of that new solution? Volume of the new solution? You take 15 and you add 120 to it. So the V2 volume is just your 15.25 plus 120. Right? Because we took 15, we added 120 to it. All right? So this is just 135.25. Do we agree? And then what's the molarity of that solution? That's where we have to use M1V1, right? got M1, V1, M2, V2. So M1 is 10 molar. V1 is 15.25. M2 is what we want. V2 is 135.25. So M1 V1 equals M2 V2. 10 times 15.25 is equal to M2 times 135.25. So I got M2, we keep in 4 sig figs here, 4, 4, and 4. So I got 1.128 molar. Does it make sense that the molarity went down, and it went down significantly? Yes, because that's a pretty substantial dilution. How do we feel about this one? Thumbs up. All right, now let's do the challenge problems. And I can't remember if there are ones like this on the homework or not. On the solutions homework. Maybe, maybe not. So we'll go over them. All right, this is a true statement. If you buy a solution in the store that's 0.95% or 3% or 10%, right? You're mostly buying water, right? You're only buying a small amount of the actual solute, whatever that is. So if you buy a 450 milliliter bottle of solution that's 9.5% ethanol, you're actually buying mostly water. What volume of water are you buying? So we need to figure out what amount of ethanol we're buying so that we can figure out what amount of water we're buying. So the fact that it's 9.5%, 9.5% means that for every 100 milliliters of solution, how many milliliters of ethanol are in there? 9.5, right? Now, there are lots of ways you can do these problems. All right, but that's the definition of 9.5%, right? Just like if I said, okay, your grade in this class is a 71.3%. Right, that would mean out of 100 points, you've got 71.3. Assuming that there are 100 total points, right? Okay, so if we've got a 450 milliliters of solution, we can just use this as a conversion factor. 9.5 milliliters ethanol for every 100 milliliters solution. Right, so solution cancels out. So 450 times 9.5 divided by 100, I came up with 42.75, right? So that's milliliters of ethanol. So out of my 450 milliliter bottle, 40, what was that? Is that 7? I can't read. That's a 2. Can't read my own handwriting. 42, essentially, are ethanol, right? The rest is water. So what volume of water are you buying? It's just 450 minus 42.75. So that ends up being 407.25. Does this make sense? So you're just using the fact that it's 9.5% as a conversion factor. The next problem works very, very, very similarly. It's just percent by mass instead of percent by volume. So let's take a look at it. Your boss tells you to go into the lab and prepare 550 grams of 15% by mass glucose aqueous solution. Does it matter that it's glucose? I mean, I could have said Kool-Aid mix, right? It doesn't matter what the solute is because it's by mass. We don't need to calculate number of moles or anything like that. So boss wants 550 grams and wants it to be 15%. What mass of glucose and what mass of water should you use? So again, we're going to use the fact that it's 15%. 15% means that for every 100 grams of solution, you've got 15 grams glucose. Right? So again, if you did this a different way and you still got the same answer, as long as I could see your work, I was happy. So 550 grams solution times for every 100 grams of solution, I have 15 grams glucose. So solution cancels. So the mass of glucose I got is 82.5. So that's the mass of glucose. So just go to your balance and measure out 82.5 grams. And then to get the mass of the water, how do you get the mass of the water? All right, so it's just the mass of the solution minus the mass of glucose. So mass of the solution was 550. Mass of the glucose was 82.5. So that's 467.5 grams of water. Does everyone see how to do that one? Okay, so that's where we're going to stop for today. Stop.